Hi, in this module we're going to be looking at working with Allen Bradley PLC data types in GP Pro EX. GP Pro EX has literally hundreds of available PLC drivers. Allen Bradley is just one part of that family, and in most respects they're treated in the same way as other PLC data types. So a lot of this is applicable to other PLCs, but there are certain features of some of the Allen Bradley PLC data types which require some special treatment in GP Pro EX, and we'll be going through those. That includes the control logics native tags. So we'll be looking at the different addressing modes that we'll come across in Allen Bradley PLCs, and looking at why the RSLogix 5000 control logics tags are just a little different, and then of course how we can use all of those tags in the GP Pro EX projects. There are three different types of Allen Bradley PLC addressing types that we need to deal with. The first one is the traditional address-based tags or registers that we come across in anything from the PLC 5 series through SLC 500, MicroLogix, etc. And these should be familiar to anyone who's used those PLCs. We're looking at designations such as N7, B3, F8, etc. The next one is a mode which is basically a compatibility mode for people transitioning from the earlier legacy Allen Bradley PLC product through to the RSLogix 5000 platform, control logics, compact logics, etc. And in this mode, what you basically have is a way to support legacy peripherals and upgraded programs that are moving from this platform to this one. And then finally, and most importantly, the cornerstone of the RSLogix 5000 software, the native tag based addressing. That applies to all of these PLCs here. We do include SoftLogix here, although we don't officially support it with our drivers. We're told that many people have had good success with that, and it wouldn't be surprising since it has exactly the same PLC protocols. This is kind of a handy map to show the way the different addressing methods are supported across the Allen Bradley PLC families. You find the regular address-based system for the MicroLogix, the SLCs, and the PLC 5s. As you transition to Flex, compact logics, and control logics, there's the compatibility mode, the tag mapping mode, which takes the place of this addressing mode. And then for the native tag based addressing, which we'll find in the RSLogix 5000 series for Flex, compact, and control logics. Note that for Proface we currently only support the native tags in our Ethernet IP driver. We are looking to do DF1 support, and by the time you're reading this, that may well have happened. So please check Proface support for the current status if you're looking for native tag with DF1 support. So alongside that addressing mode map, we now have a map of the Proface hardware which supports these various drivers. And what we find here is the DF1 serial driver, typically RS232, and that is supported across almost every part of our Proface family. The exception here is the LT3000 family, which is a standalone controller with its own PLC functionality, and that therefore does not have PLC driver support. So you'll see X's all the way across the bottom, just as a reminder. So DF1 available on pretty much everything. DH485, this is the multi-drop serial, is only available on our AGP series and our AST series, that's due to a special chipset and therefore is not found in our industrial PC range, the APL and the PS3000. And then finally the Ethernet IP, some X's in here. These are the low-cost AGPs, and these are the ASTs, the low-cost range, the entry level, and neither of these have an Ethernet port, so guess what? No Ethernet IP support. When we're making connections to Ethernet IP, Allen Bradley has some recommendations about the maximum number of connections. From a GP Pro EX point of view, we can make up to 16 different PLC connections from one AGP or one Proface HMI. But as you can see here, for the various families, Allen Bradley recommends a maximum number of connections which range from 4 to 16. These 4s here are all when using the 1761 Net Any, that's basically the serial to Ethernet adapter. I would recommend though that these are guidelines for maximum connections. The performance level will vary widely. We've noted that particularly some of the micrologics do not have great response over Ethernet, and you really want to either try that out or consult with Proface support if you're considering putting a large number of Allen Bradley PLCs onto a Proface HMI using Ethernet IP. So let's go back to the traditional addressing modes used on PLC 5 through SLC 500 and Micrologics. This is typically how your ladder logic is going to look. There's a B30 here and N70, and what they are is it's a fixed data structure. The letter typically gives you the data type, so integer, bit, float, etc. And then the next digit will be a file number. It can be anything from 1 to 100 or possibly more. And then finally an element number. So within N7 we might get 0 through, again, 100, 200, depending on the PLC. For bits, where we choose bit files like B30, we might have B30/14 to break that down into an individual bit. Note that when you're using this type of addressing, you can just enter them straight into GP Pro. You don't have to do any import export. If you know the name, the designation of the address that you want to use, you can put it straight into GP Pro EX, and that's what I'll show you now. So here I'm about to start a new GP Pro EX project for a GP3000, an AGP 3300T. Next thing I'm going to do is to choose a driver. I'm going to cheat and choose the Rockwell DF1 driver I used recently. I won't go through the communication settings in this presentation because we're going to do a whole separate presentation for that. So instead I'm going to go for a new screen, and I'm going to choose an object, in this case a data display, and I'm going to place that data display on the screen. It gives me a default bezel and a default numeric format in there, and if I double click it, you'll also see it gives me a default PLC register. We can have up to 16 individual PLCs per driver. By default, the first one is called PLC1, but you can change that name to something more applicable. Now I can edit the straightforward PLC address. Then I'm going to try to use all the help available, and that includes the drop-down menus. I can choose my N registers, my B registers, my timer, and counter registers, etc. And each time I do, you'll see that the boxes on the right hand side change. So for a counter, I by default talking about counter 5, number 50, the preset or the actual. Notice that things like the timer enable and other bits are not shown here. That's because they're not applicable for a data display. For a simple B register, I can choose B350, but not the individual bit, because again, this is a data display. So we're typically going to show either an integer or a floating point value. Okay, so there's boring old N70, and then I can choose data formats to display that in. That's really all there is to it. I haven't had to import the data from the PLC project because I understand the structure and the numbering system, so I can just type them in. Same is true if I choose something like a lamp, which would be typically from a bit. And so I put the default lamp on there, and again it shows me a default bit. Note that this time the file and element number now includes a sub-element which gives me access to bit 0 through 15. Let me enter that as so. Similarly, I could take a data display and choose a floating point value. This time I'll choose F80, and I'll make sure that I set my format to suit showing a 32-bit floating point value. If you prefer not to use direct addresses within the project, in other words, if you prefer to use symbolic addressing, GP Pro EX supports this in a couple of different ways. First one is from the symbol variable list, you can type in my symbol, and then you can assign, based on whether it's a word address or a bit address, a corresponding PLC address using the same syntax as we did before. So this time we enter my bit, specify it as being a bit address, and then again choose an appropriate bit number in the same format. So that's all well and good, and the nice thing about that is that if you are trying to reuse a project on a different PLC, you can actually export this symbol list, modify it for a completely different PLC, re-import it and reuse it. Another way to use the symbolic addressing is if you have RS logics and you define the symbols within there, assign a symbol such as B30 is bit 3, or timer 4 enable as timer 4 enable. The accumulated value T41 is second timer. Note that you don't assign a symbol to the entire element, the entire set of elements here. You assign it to the bits or the words appropriately, and that's kind of important. So what you see if you look in the database is the bit address, the symbol, and an optional description. And here the symbol group, which can be used a number of different ways in RS Logics. It's really helpful if you use this to define the element type, either a bit or a word, or use bool and int. And you'll see why as we try to import this into GP Pro EX shortly. So there's these are the symbols that I've given names to, the address. The symbol group is either bool or int, and then an optional description. Okay, so what I'm going to do is I'm going to export the database to a CSV file called test.csv, and I'm going to put that on my desktop, overwrite the existing file, and there we have it. Now you'll see that back in GP Pro EX there is actually a utility to both import and export, but if we look at the import, there is a GP Pro EX format which allows you to define a lot more fields. But when you're importing from another PLC, such as the Allen Bradley RS Logix 500, you can pass other formats. And what happens is this: you choose other formats, you choose the CSV file that you're interested in, and all it's really interested in here is it wants to see 4 columns which give you the name of the symbol, the type of the symbol, the actual address, and an optional comment. Now it just sticks those 4 headers up there, but as in this case you can see that that clearly isn't the name column, that one is, and that isn't the address column, that one is. So you can just easily and quickly change those around. So that's now the address column, that's the name column. That also isn't the type column. That actually we found all the way over here. And that lets me, that's that symbol group that I used for this purpose. You can specify for the type format a different type of name here. The default is bool and int. You can use something else. But that just saves a lot of time and means you can do this whole process with one pass. So with all the columns all together, the majority of these don't have names and therefore nothing will happen to them. But if I say OK, then you'll see that all the ones I have defined have now come in and are set up as word addresses, bit addresses with the appropriate symbols and comments attached. We'll now move on to that compatibility mode that we talked about earlier. This is where you've upgraded from SLIC or PLC 5 into the ControlLogix platform, but now you want to access the data in a sort of a ControlLogix native tag kind of way. And basically the trick here is that the RS Logix 5000 software provides this PLC 235 SLC mapping, and so a RS Logix 5000 array has to be a simple array of either bits, words, floats, etc. is created and assigned a file number, and the file number basically links back to the original SLIC or PLC 5 file number. So for example, here we have an array called control bits with file number 20. This was actually originally B20. In the RS Logix software you use the actual name, and there's a name and an array element, but when you communicate to the ControlLogix device you use a simpler structure, something more akin to the original B2000. It's called bool as opposed to B, but it's essentially the same thing. So all your original data files, your integer file is now file number 7. You can give it any name you like. You can call it N so that it would be N7. You could call this F so it was F8. You can give it a full name. Really, in the communication side, all that really matters is this file number here. So I can communicate to this one as integer file number 7. And I think a picture paints 1,000 words there for sure. So I'm going to show you how that works in practice. Rather than start a brand new project this time, I'm going to show how I can add an additional driver to this existing project that we used earlier. So what I'm going to do is I'm going to go to the PLC list, and I'm going to add a PLC. I'm going to add a Rockwell PLC. I might as well stick with DF1. I'm going to put it on COM2. What I'm going to do down here is I'm going to change its default type from SLIC to control logics. This is DF1, so I'm going to be using the PLC mapping version of that with the control logics. Now I'm back at my screen. I go to add a new device, another data display like we did before. This time when I go to enter the data, I'll find that in addition to PLC1, which has the traditional SLIC addressing, PLC2 now has one that deals with bools, ints, reals, etc. In other words, this is the compatibility mode for the compact logics. And if I've upgraded a SLIC to compact logics or control logics, then typically the equivalent of N7 would be int7, the equivalent of B3 would be bool3, etc. So it's very simple to use. And that's really all there is to that. Same example with a lamp. This time choosing PLC number 2. I see only the compatible. I can of course take a bit out of an integer. That'll work too. And that's really all there is to the compatibility mode. The use of that mode is set up on the Allen Bradley RS Logix 5000 side. Now let's move on to talk about the native tag addressing that you have with the Control Logics, Compact Logics series from RS Logix 5000. In this case, we have what appear to be symbol names, start machine, but unlike the RS Logix 500 or the SLIC-based systems, this is not a symbol that equals N70 or whatever. The symbol is the tag. The symbol name is the tag name, and there's no equals, there's no cross-reference to that. So the advantage in Control Logics is that those native tags can allow you to have real common language names like start machine, and in addition you can build up complex data structures so that ultimately you could have a whole machine or process defined by a single user-defined structure that contains all the parameters for that machine or process. And there are a lot of advantages to using that kind of approach. The only problem for us from a HMI perspective can be that the resulting tag names are long. You could have a tag name that is my machine dot start machine dot whatever and carry on with a big long name, and that makes it hard to type in when we're looking at using that in our HMI. So this really makes it imperative to export the tags from the RS Logix software, import them into GP Pro EX, and then have them available from a drop-down list that will mean that we don't make mistakes in typing, etc. So the native tag structures can be broken down into what they call controller scope or global tags. That's tags that are available to the whole of the PLC project. Program scope is where you have individual programs within a single project broken down, and you use a local name which you can duplicate in other programs. We can talk about that later. Then we have the predefined structures, the bools, the strings, the reals, etc. Then we have the module defined structures. This is essentially how the control logics accesses its I/O. And again, a module defined structure can have a mixture of bool, int, string, dint, etc. And then there are the user defined structures. That's where you decide that you want to create a structure that has multiple data types, multiple arrays, and are specific to your application. Now the good news is that with all this increased level of complication, we could be creating a HMI nightmare, but fortunately not for Proface. We have tackled this data structure head on and produced a really neat way to export the tag data from RSLogix, import it into GP Pro EX, and do that really rather simply. So normally the RSLogix 5000 software, you save your project file and it has a suffix .acd, and that's a binary file. So what you can do is you can choose instead to save as and choose a file type which is .l5k, and the L5k is a text-based version of the ACD file, which means it's much easier to open up with WordPad, etc., and actually read it. You can also do an export of just the tag names to a CSV file for GP Pro EX to import, but it's not really a good idea there, especially if you are using any of the complex data structures, the module defined structures, and so on. So if you use the L5k version of your project exported from RSLogix, then it's going to be much easier to get all of your tags, all of your data structures straight into GP Pro EX in one fell swoop. And on the other side, in GP Pro EX, once you've saved your project in that L5k format, what you do is you choose the version of the driver. Unlike the tag mapping, the PLC mapping version that we had before, we choose the one called native. And once we've done that, we can now import the entire L5k file into the GP Pro EX database. And I'm going to show you how we do that. Here we have a sample application in RSLogix 5000, and as you can see, this is the ladder logic. Here are some of the tags in use: pf tag bool, etc. We want to take a full look at that list. There it is, whole series of tags. Some of them simple string, synths, reals, and then others are more complex, and we can break those out and take a look at them. These are some user-defined structures that consist of bools and ints. Other data types that are around here are the user-defined structures. There are 3 that we've defined there. There are the predefined string data types, a whole bunch of predefined data types for dealing with a variety of I/O and application situations. And then the module defined ones, which are principally the I/O data types. And if you take a look at one of these, you'll see, for example, that this is a structure for an output card that has a series of double integers or dints and a boolean, and all contained within that one data structure. So what I'm going to do is I'm going to go to File and go to Save As. And here we have the default save type, which is the ACD format, the binary format. I'm just going to change that to L5K, and I'm going to overwrite one that I prepared earlier. I'm going to replace that one. I'm exporting all the tags. That's it, done. I'm going to go back to my original GP Pro EX program, and this time I'm going to swap out the ControlLogix DF1 driver for the Ethernet IP one. That goes something like this. There's the existing PLC2, and I'm going to change the driver to native tag. As soon as I do that, I get a prompt to import a new database, which I'm going to do. And I'm going to pick the one that I had just saved. It reports that I've imported 3 user-defined structures, 37 tags, 6 aliases, and 5 module-defined structures. Now if I want to, I'm actually all done, but if I want to see how that worked out, I can go into edit mode and I can view all of the available tags that came in from the project. Say OK to that and go back to my screen. And now what I'm going to do is to go back into the PLC2 that I had. It's now undefined because I changed the tag structure. And this time when I click on PLC2, notice how the drop-down menu changes. Instead of putting in N7s or bools and ints, I'm just faced with a list of all of the available tags. Notice that some of the tags are grayed out. This one is okay, it's a SINT. This one is grayed out because it's a bool, and you can't use a bool in a data display. So that's kind of handy. And I can pick any element of the array. This is a 2-dimensional or even a 3-dimensional array. I can choose element 1, bracket 2, bracket 5, or 4. And that's really all there is to it. Much simpler to use than having to remember addresses. The data structure is all in place for you. Open up a lamp. Now I'm using a bit. Choose PLC2, and this time I get access to most of the symbols, on the grounds that even with some of the integers, I can pick out a bit within an integer. So I can pick out bit 0 through 15 for that integer. And that's really the top and bottom of exporting native tags from RSLogix 5000 and importing them into GP Pro EX and applying them. So that's the end of this module on working with AB PLC data types in GP Pro EX. I hope you found that informative and can see that not only do we have full support for those Allen Bradley data types, but also that we make it as easy as possible to use, thereby saving you time and money in your applications. For those of you who are interested in knowing a bit more about the native tag side of the import-export options, then you may look out for that in a separate module as an addendum to this module. Thank you very much for your time. There is a short feedback survey at the end of this presentation. Its completion is optional, but it shouldn't take more than a minute to go through it. Your cooperation helps us to continue to improve our quality of service. If you have any other training questions, please email them to training@profaceamerica.com.